Oh, back again. Whoa. Just juggling some carrots there. Yes, you need angular momentum to juggle carrots because they're not like a ball or something easy to juggle. So you need to spin them. So you need to spin the carrots or whatever object that's long versus round. And we needed angular momentum to do that. So yeah, back to talk a little bit about angular momentum. Spinning stuff, angular momentum. So angular momentum, we say capital L, mass times velocity times the radius, right? So we're going to be spinning an object, and we can think about this in terms of vectors. So we've got a cross product. In this case, we've got the velocity 90 degrees with respect to the radius, all right, or some other angle in between. And the angular momentum will be perpendicular to that. So in three-dimensional space, this would be the angular momentum. So it points out of the plane of the velocity and radius. So you can see that in your physics textbook. So angular momentum, an interesting concept. Spinning objects. I've got a pendulum here, a friendly happy face pendulum, all right? I'm going to be swinging this. Now if I swing the pendulum back and forth with the pendulum, it pretty much flows freely, right? Back and forth, up, down, so on. Would the same type of behavior happen, for example, if I were to hang this plate off of a string? So here's a plate, got a fishing line here in the plate. What would happen if I were to just let this flow? Yeah, it would kind of wobble back and forth, okay, sort of like a pendulum, but the plate goes wobbling around. Can I get this plate to stabilize somehow? What if I were to spin this plate, put an angular momentum? So I got a torque, creates an angular momentum. What would happen to the plate? If it's spinning, would this plate, for example, do like the pendulum and angle like this, sweep up like this, and back, and meaning like this? Or would something else happen? I'll give you a little hint. It may not look like this, it may end up looking like this, okay? I don't think you can put drinks and snacks on the plate, but let's give it a good spin and see what happens. So here I'm going to put a big spin on this plate, okay, and look what happens. Oh my goodness, it stays straight, so it doesn't angle up like the pendulum did. So as it sweeps through, we've given it angular momentum, so it stays spinning in the plane. See, it stays spinning in the plane. No matter how high I swing it, it stays spinning in the plane. So it doesn't want to steer out of the plane. So once you've given it a torque, generated an angular momentum, it stays straight. And very useful, for example, if you want to juggle different things. So I tried the carrots earlier, got some toothbrushes. Here's the toothbrush. If I just take these 3 toothbrushes and throw them in a haphazard way, I'll probably end up dropping all of them. What if I spin them, give them angular momentum, right? They're going to want to stay within that spinning plane, and I can throw them, right, give them a trajectory, but they're going to spin in that plane and fall, you know, like any other object as a parabola, but I can spin them, give them angular momentum, and be able to juggle something that would be very difficult to juggle if I didn't give it angular momentum. So drop them eventually, but there you go. So giving things angular momentum can make something that's really difficult to juggle much easier to juggle. So finally we have these donuts here, or toruses or toroids. I don't know if you're a mathematician, but so we're going to give them angular momentum, right? Spinning, so they want to stay spinning. So here we go. You ready? Didn't say this was easy, but okay. So I'll see you in the next segment. Take care and use angular momentum. Okay.